Lorna Patterson, Grade 2 at Zurich International School.
We learned about geometry and
Student-led inquiries in mathematics. Catherine's inquiry.
Catherine said to me, I looked at the triangle and I saw it had 3 sides and 3 corners. And then I looked at this shape and I saw it had 4 sides and 4 corners. So I think that the number of corners is always the same as the number of sides. That is a great investigation that we could do.
yeah, it is.
Isn't that a really good investigation that we could do? We could get our 2D shapes out and we could investigate if Catherine's, we call it a hypothesis. She's made a guess, she's made a statement she thinks might be right, and now she's going to go back and check, is it actually right? So,
This doesn't have any corners. This doesn't have any. Well, it does have one
you might want to do a chart.
because then it was
Got sides and corners. I would also in girls so far. So that's the same, okay. Cut. Or, okay, so let's look at the shape. How many sides does the shape have? What is that? It's one shape to me. Okay, so can you point to a side of the shape? Yeah, but what is a side? That's a corner. Okay, so what is a side? The corner is 2 lines right together. So these are the corners. So let's count the corners. One. What's your next one? Okay. And the sides are the plus. And then the plus. 1, 2, and 3. Okay, so Catherine's original hypothesis. What did Catherine say originally? She said that. What did she originally say? What were we investigating? August.
If every single, if all of the shapes would have 2D shapes,
Okay.
would have
All 2D shapes have the same number of corners as sides. That was Catherine's original idea. Now we've done some investigation. Do you agree or disagree? So first of all, if you agree with what Catherine said, can you put your hand up? If you disagree, if you think she was incorrect, could you put your hand up? Who would like to explain? Who could explain to us exactly what is happening? Now, let's ask Catherine. Right, Catherine, stand up. What did you find?
that if it has more than if it has 2 sides or more, like the circle doesn't have any corners, it only has 1 side, but no corners. If it has 2 or more sides, then it's true.
Okay, so if a shape has 2 sides or more, then the number of sides equals the number of sides is the same as the number of corners. Is that what you're saying? Do you agree with that statement?
Yes.
What shape was causing the problem?
Circle.
Circle. And Chloe found another one that caused the problem. An oval. A circle just has how many sides? 1. How many corners does he have? 0. And the same with the oval, he has 1 side and 0. So Catherine decided, well, okay, it's not true, but could I make the statement true? And she changed it a little bit. And she changed it to say, if a shape has 2 sides or more, 2 or more more sides, then the number of the sides is the same as the number of the corners. So that's our next hypothesis. Okay? Superb. It's time to Chloe, what's your wondering? Why does a circle have no corners?
Because it's a circle.
Why does an oval have no corners?
Wait, then why does a triangle have corners?
Why does a triangle have corners? Is it useful that a circle has no corners?
Yes. Yeah, because otherwise you wouldn't be able to try.
Jack's inquiry.
Now, this is actually one that Jack Dilworth came up with. He said to us, if you put two triangles together, you get a square. And we wondered if that was true for all triangles. So on this table, I have lots of different types of triangles. And you're going to find out, is that true? We'll have to find out. On a post-it note, write down what you think now. So originally we thought that if you could put two triangles together, you would get a square. I would like you to do some inquiring, some investigating, and come up with what it is that you think now. Okay?
Anna, what have you made?
A square.
And what have you used to make it?
Two triangles.
Two triangles.
But if you rotate the square, it'll turn into a rhombus.
Right, well what's different about the sides of a rhombus compared to the sides of a square?
A rhombus has only.
How could that? Then you she has
To make them fat
and then you
I think I want to investigate what's different about rhombus and a square.
Okay, how are you going to investigate that, Anna?
By I don't know.
Have you got a rhombus and a square there? You know what, Anna? Why don't I write that question up and we'll put it on the window and we can investigate it together?
I'm not sure that you can make it out of every triangle. Because look,
Uh-huh.
you have to make it a little bit of a long triangle to make a square.
So it depends on the type of triangle you've got.
Yeah, the type of size it is, how long it is, the length. Because look, if I put it this way doesn't even make a square. If it's longer, like this, then you can make it.
Kira, what do you think?
I think that if you take two thin triangles, it won't make a square.
What do you mean by thin?
Thin means this one is more, like pointing up, and this one is a bit more pointing.
Ah,
A square out of these big red ones.
okay, let's check.
Yeah, you can. Yeah, you can. You can.
Okay. Why do some triangles make squares and other triangles don't?
Because they have to be the right size triangle. Because these ones are a good shape because they're both a bit thin and a bit pointy. So they can make triangles. But this one is too pointy up, so it can't make a triangle. It can only make a rhombus. And this one is too thin, so it only makes a really thin rhombus.
Ariel, what do you think?
Maybe because, one is uneven, but these two are the same.
What do you mean? What is uneven and what is the same?
This is long, and these two are different. So they're not all the same size line. This is longer, these two are the same.
Okay, so it's got two sides the same and one longer side. Does that have to be the case for two triangles to make a square?
Not that
Okay, why don't you do some more investigation then?
I think it depends on how the sides combine together.
Okay, thank you, Louise. I think it's time to inquire into right angles, and Anna's question about the difference between a square and a rhombus leads us nicely into that inquiry. Activating the children's background knowledge through exploration and questioning allowed me to pre-assess, and it also stimulated student wonderings.
So what Ariel's done is she's made the big one out of small ones.
This is the same shape, but just in a smaller version. And these four altogether equal the same size and same shape.
Do you know the name of those shapes?
Not really.
No.
I do.
You do, Anna?
This one's called a rhombus. Everyone calls it a diamond, but that's the real name of it. Actually, diamond is a completely different shape.
What is the difference between this kind of shape and this kind of shape?
This one
Do you know the difference between?
yes, because this one is 3D model.
Oh, and this is what we call these kind of
Also,
shapes.
it doesn't look like anything like this because it has like, if it cuts this in half, it'll make a triangle.
What are you using? Is this a square? It's 3D, and what's its name in 3D? Cube. So is there anything square on this cube though? Where are the squares on this cube? Do you know the name for these parts of a 3D shape? Well done, Ray. It's face. So the face of the cube is a square. Excellent. Good work, girl. A cheese factory. Ah, what is it that's making you think of cheese while you're building this? You love cheese. Oh, you're right. Cheese is special to Switzerland. Do you know the name of any of the shapes you can see? A triangle? Okay. Anything else? Okay. A cube or a square. What's the difference between a cube and a square, Victor? Do you know the difference? Can you show me how this cube relates to what you were showing me earlier?
If you put this like this, it looks like this, but it's just like upside down, like this down, because you can see the up, the side, both the sides, but the bottom you can't see. So if you put it there, you can see the sides, and it's like when you draw it, you can see it like it's real.
After the exploration time, I realised that I needed to focus on building the children's shape vocabulary. For example, the 2D shape names, the 3D shape names, the names for the attributes, and also use of the words congruent and similar. They seem to have quite good conceptual understanding, but don't have the vocabulary to express their knowledge. So I decided to investigate a little further.
So these are quick images. It goes up, 1, 2, 3, and then I hide it again. And then we'll put it up again, and you can check your shape, and we'll talk about what we see. Okay?
Yeah.
Alright, first shape, are you ready? Yeah. Draw the shape you saw on the board.
I already did that.
No. The F is just for me, so I know what shapes I should. Okay, I'm going to put it up again. If you need to make any changes to your drawing, then now is the time. So, look at the drawing you've got on the board. Check what's on the smart board.
Yes, tick.
Is that really what you see on the board?
I see a square, not a rectangle.
So Jack, you're changing yours, are you?
Yeah, it was more like a rectangle.
So before you had like a rectangle, now you're changing it to look more like this.
This is a square.
Pens down, boards on the floor in front of you. Just could you turn and talk to the person next to you? What do you notice about the shape that's on the board? What do you notice about the shape that's on the board? Okay, 3, 2, 1. Are you ready? Could you tell me something that you were talking about with your partner? What did you notice about the shape that's on the board? August, what did you notice? Sorry? That it was a square? Ruby? It has 4 sides, okay? Good.
And it's going to
It has 4 vertices. What's a vertex? Okay, lovely. Good language. Catherine? The length of each side are all the same. So we've got 4 sides. Each of the sides is the same length. We've got 4 corners or vertices. Anything else you want to add, Ethan?
I was going to say the same.
Okay. Alright. Back. It's a 2D shape. Excellent. Flo, can you tell me more about what 2D shape is?
2D shape is not like a 3D shape. It's like this is a 2D shape. Like this would be a 2D shape. And it looks like it's put on the floor. It's not like a little bit to the side.
Yeah.
Like something else would be like this. Like something else would be a 3D shape.
Alright, ready for another shape?
Yeah.
Okay. Right. Wipe
Can
the
you
boards.
flash it off for a slower time? Can you flash it for a slower time? Like 1 second? Like, no.
Okay, are you ready? Next shape.
Easy. So easy.
In order to learn more about the relationship between 2D shapes and 3D solids, we decided to learn how to draw 3D solids all by ourselves. Sat down together and as a class came up with the success criteria for drawing a 3D solid. As you can see, we were very successful. High value is placed on building children's learning power. While learning to draw the 3D shapes, we were working on persisting in our learning even when it's challenging. Using a split screen method, the success criteria for drawing the 3D solid and also the success criteria for persisting in our learning was available to the children. At the end of the lesson, we reflected on the success criteria of both parts. Book Creator app is one of our favourites, as it is a great vehicle for allowing the children to explain their thinking in both written and audio form. Furthermore, it's easily published to our individual classroom blogs.
Before we go out and we start our maths, the first thing we have to do is we have to start a new Book Creator book. So if you could lift up your iPad and press the Book Creator app. We've done this many times. Okay, we are going to make a new book. So up here in the top corner, new book. I would like this book to be a square book. You know my favourite book is the square book. No? Okay. The first thing that opens up is this blank page, and it is the cover. The cover of this book must have a title on it, and the title for this book is going to be
3D solids.
Sorry. Oh, my finger's not working. My shape work. Looks kind of boring at the minute. Is there anything we can do to make my title?
Colors.
Add some colour, change the font. So if you press the I up in the top corner, I'm going to make my font red. And I'm going to change it to that one's my favourite. And I'm going to make it. I might change the colour of my page as well. Oh! That looks nice on my iPad, but not so good on the screen. Let me change the colour of my writing so you can see it.
How do you make it look good?
Well, you can, if you tap the text and then press the I up in the corner in front, it gives you options there. You can change the size, you can change the font, you can change the colour, you can change the have my shape work book front cover made up. I had to change the background like this, the background of the text last year of one of the boys in my class. So quite often you guys are the ones teaching me things. 1, 2, 3. iPads face down on the floor in front of you.
Without putting it on?
Okay.
Now, I'm actually
You now have a book made that you're going to put all of the shape work that we do today in. Now, at each station for maths, there is a piece of work that you need to do, and the last instruction says, photograph your work. After you've photographed it, you need to add that photograph into your book creator book, okay? I don't have anything for maths up at this moment. So if I had been doing my shape work, and this was the photograph of my shape work, I would add that into the page. And we'll go back and we'll add headings and everything in after we've done our shape work. But as you're going around, please put the photograph of your math work into your shape book. Okay? So you will need to take your iPads with you today around the tables for the math.
If you made it this far, all the way to the end, then thank you very much for watching.